Kia ora koutou, welcome to this next video in Chemistry 2.4, Demonstrate Understanding of Bonding Structure, Properties and Energy Changes. In this video we are looking at the properties of molecules. In the first video that we've done in this series, we looked at all of the different properties that can be assessed in this topic, and so here they are here. For molecules, the two important properties that we need to be able to explain are melting and boiling points of molecules and solubility. So molecules at room temperature tend to be gases. They can be liquids, like for example water, or even iodine would be a solid at room temperature. But in general we won't be asked about hardness, malleability, ductility or electrical conductivity because they're not really relevant to molecules. So we're just going to focus on melting and boiling points and solubility. So melting and boiling points of molecules. If you remember, the differences between solid, liquid and gas states are that for solids there are strong forces between particles, and so the particles in a solid are not able to move past each other, and they will use up a fixed space. They will not flow and use up any of the room in a container. In liquids, the forces between particles are weaker than in solids, so the particles are able to flow over each other and they would use the full space available to them at the bottom of a container. Gases, for gases, the bonds between these particles are now broken, so there are no forces holding these particles together, so they will use up the full volume of any space that they're able to. So as we go from solid, liquid to gas, the forces holding the particles together are getting weaker. So the thing that would break these forces apart is kinetic energy of the particles. So kinetic energy is effectively temperature. The greater the temperature of a substance, the greater the kinetic energy the particles have. So for some substances, the strength between the particles will be very strong, and so it will take a large amount of kinetic energy in order to break those bonds and move the substance from a solid to a liquid to a gas. In other substances, the strength of the bonds between the particles will be very weak, and so it will take very little kinetic energy to move the substance from a solid to a liquid to a gas. So in molecules, they have relatively low melting and boiling points, which indicates that the strength of the bonds between these particles is weak, and we will have a look further into that. So if we look closer at each of these particles, we'll make the assumption that what each of these circles represents here is a nitrogen molecule. So nitrogen forms about 78% of the air, and nitrogen, when it's in its gas form, or its elemental form, is actually two nitrogen atoms bonded together with a triple bond. So each of these blue circles represents one of these nitrogen molecules. So I will draw that in to make that easier to visualize. So we've got two nitrogen molecules here. So it's the forces between these molecules that are important when we're talking about melting and boiling points. So there are actually two different types of bonds or forces that we are looking at here. So first of all, this is what we've gone over previously in previous videos, is the bonds between these nitrogen atoms. So those are called covalent bonds, and you might also see them referred to as intramolecular forces. So they might also be referred to as intramolecular forces. So what this means is that the forces, covalent bonds, are forces inside a molecule. I don't know why this isn't moving. There we go. So intramolecular forces are covalent bonds. They are bonds or forces within that molecule. What we also have, and what we haven't gone over in the past, is intermolecular forces. So we don't need to know why this happens. but we just need to know that they exist for molecules, and for molecules they are relatively weak. So here we've got intermolecular forces. Intermolecular forces. So because these forces between these nitrogen molecules are weak, it requires very little kinetic energy to overcome these forces. So that means that there's, at a low temperature, these bonds between the molecules will break and the molecule will go from a solid to a liquid to a gas at a very low temperature. So nitrogen actually melts at negative 210 degrees Celsius. And to put that into perspective, a substance that has strong bonds holding it together. They're not intermolecular bonds in this case for sodium chloride, because sodium chloride is made of ions and not molecules, but the bonds holding the ions together for sodium chloride are very strong, and the melting point of sodium chloride is very high. So sodium chloride has a melting point of 801 degrees. So putting that into perspective, the melting point of nitrogen is negative 210, which has weak intermolecular forces, whereas sodium chloride, which has strong bonds holding it together, has a melting point of 801 degrees. We'll leave that video here for the moment. So in this video, we've gone over the melting and boiling points of molecules. In the next video, we'll go over the solubility of molecules. Thanks very much for watching. Like and subscribe for more chemistry videos. See you next time.